Hi, I assume you have seen my latest tutorial where I showed you how you can use animation nodes instead of a particle system to generate like random starting positions of objects. Then Daniel on YouTube asked, how could you instance multiple objects like from a collection? Because in the particle systems in Blender, you can instance the particles from a collection, and the particle system takes a random object for each particle out of a collection. And in this video, I'm going to show you how you can do something just like that. And you still have all the benefits of the stuff that I talked about in the last tutorial. Like, for example, you can still go in and change the objects, the mesh data, even like physics data, like the cloth pressure or stuff like that. Let's get started. Alright, I'm back in Blender 2.91 Alpha. Let me see. 2.91 Alpha. It is a very recent build. I think I downloaded this yesterday or 2 days ago. And I also have the latest animation nodes downloaded from Graphical. Now in this tutorial, like I said, we're gonna start off by creating a few objects and putting them into a collection. So how about we just create maybe a cube, and we can create an icosphere, move it over a little, and then let's also create a torus, or as it's known in a Blender circles, a donut. The infamous Blender donut with pink frosting. So, okay, now I have these. They are already in a collection, but of course we could put them in their own, move them into their own collection if we have other objects. I'm just gonna take this collection and I'm gonna call it objects. Doesn't matter what it's called, but I will use that collection now in animation nodes to get these objects out. So let's go here. Let's go to animation nodes, create a new node tree, and switch this over like this. Now you might be thinking, well, this is kind of easy. We have 3 objects. We can create a loop that iterates through these 3 objects from the collection, and then we can create an object instancer inside of that loop to give us the instances, the particles, let's call them. And although that makes perfect sense, it is not possible in animation nodes because you cannot put an object instancer inside of a loop. It like completely crashes animation nodes, so I'm not going to show you. You can try it out. Instead, we have to do something else. First of all, we have to get the objects out of our collection, and that's very easy. We can go to Shift A, Object, Collection, and here we have the collection info node. And it gives us the objects of a collection. So here we have only this one collection here called objects. And now this is a list of 3 objects, right? Yes. So these are our 3 objects here. So let's say we want, I don't know, 30 particles inside of a cube, randomly distributed inside of the volume, just like what we did in the last video. So we just need some random vectors, right? Random vector, we need a list. How many do we want? 30 probably. And for that, I'm just gonna take an integer input, type in 30 and plug that into this count here. So here I have a list of 30 random vectors. And now I can create 30 objects from this collection. And the way I do that is not by creating a loop through these 3 objects, but instead I'm going to create 30 new empty objects with empty mesh, because these are mesh-based objects. So the way you do that is you create an object instancer, just one, because we can't have... Okay, so the issue here is, since we can't put an object instancer in a loop, we would have to create 3 object instancers for our 3 objects, which is fine, you can do that. But what if you delete one and you only have 2? Or if you add 2 more, then you need 5, and you have to go back to your node tree and completely reconfigure your node tree. And it's also very bloated because basically what you're doing is you're avoiding the loop and you're creating the loop manually. Like I said, instead, we are going to create 30 empty objects. And the way to do that is you switch off copy from source on the object instancer. And you can say, okay, I want mesh objects. How many do we want? 30, right? So this many. And look over here, we now have 30 empty objects in Blender. I mean, they have nothing in them yet. And we have to fill them somehow. And you fill them with a very cool node, which is the copy object data node. So you can go to Shift A, object, copy data. And you can see here, it says copy object data from 2. And it gives you a list 2. So you plug it in 2 object lists, you get out an object list. So let's copy data to our 30 objects that we have here. But where do we copy them from? Well, we want to copy them from these 3 objects. So what we need now is a list that we can plug into this from socket here. So we need a list of 30 objects made up out of these 3 objects. And that's really very easy to do. We create a list by going to list, repeat. We take our objects here, whoopsie, like these 3 objects from the collection, and we repeat it to a certain length. The length is going to be 30. So if I plug in a viewer here now we have a list of 30 objects that we can see here. So we have a cube, an icosphere, a torus, a cube, an icosphere, a torus. Okay, we have a list of 30 objects, which are these objects now from the collection, and we can plug that in here. So now we're copying the data from these objects to our empty new mesh objects. So now they're not empty anymore. And now with this, we can actually place them to these random locations. Let me plug that in like this here. So we can just go to an object, transform output. We want to transform those 30 objects. We want to transform the location to those 30 random vectors. And down here, we can increase the scale. So now we have this. Okay, this looks kind of boring. So we also want 30 random rotations, random Euler. Again, oops, I have to switch this on to get the count so that this node generates a list. We can rotate and random rotation. So now we have 30 random particles out of our original 3 objects that are inside of this collection. If we add a 4th object now, well, let's just do it. We add mesh. Let's do a cone. Okay. GX, move it over here. So now the cone is also inside of this collection. And this didn't get updated now because we didn't change anything in the node tree. So we can go over here, execute manually. And now we have 30 objects made up out of those 4 original objects from our collection, right? Now remember, in the last video, we made starting positions, randomly generated starting positions for cloth physics simulations. Like every object was a cloth sim object with pressure in it, and that gave us those flying pillows. Now, using this method here, we're not copying a source object to a new, or instancing to a new object with all its modifiers and all of that. Here we're just creating an empty object, filling it with the data from our 4 original objects. And by doing that, those objects are still very naked. They only have the object data, so the mesh data basically, in this case. They don't have any modifiers. Physics sims like the cloth and the cloth pressure and all of that are modifiers. So how do we have to do this now? The answer to that question is we have to do it inside of animation nodes. So here we have the object. We can also switch on deep copy, which, does this have a tooltip? Yes, which creates independent objects, which is what we want for physics simulations. So this is important to switch on. Otherwise we only have like references to the original objects. And if the original object in the cloth simulation or the physics simulation behaves in a certain way, then all of its copies will behave in that way. But that's of course not physically accurate. That's not what we want here. So we switch on deep copy. The switching on deep copy doesn't copy the modifiers though. So first of all, let me go back in here. Let me delete the cone. I just want those 3 here. And let's go in and let's go to the physics tab, turn this into a cloth object, scroll down, switch on pressure and give it a pressure of 2 maybe. Then the cube here is too simple. I have to go in and subdivide it a little so that it makes sense to switch on cloth. Go down here, pressure, I don't know, 3. And then also this guy, cloth, pressure, whoops, and 5. Okay, so now the original 3 objects have a cloth simulation assigned to them. And if I execute my node tree now and I select one of those generated objects, you can see it doesn't have cloth sim added to it. None of them have a cloth sim. So basically if I hit, let me just save it quick. Okay, so if I hit play now, you can see my original 3 objects are part of the cloth simulation. They have pressure, so they get like inflated. And they're falling down because of gravity, but all the other objects don't have any cloth. They're not part of this whole simulation. So what can we do about that? We have to go up here, look at this. We can see that cloth is a modifier, and we actually have to copy the modifiers over as well. So how about we go to object, copy modifiers. There's a node for it. Look at that. So we can copy from our original objects or from our list of 30 original objects to our new list here. Let's do that. So we copy from here to this list, and this is going to be our new output list. Now let's see. Now look at that, all of our copies now have cloth sim added. So what does that look like? I hit the space bar and we can see, yes, they are all kind of falling towards the ground, but it doesn't look like they have pressure assigned to them. Why is that? So this guy here, the original icosphere, let me also go in and subdivide this just once, has a cloth on it, and it has a cloth pressure of 5. But the copies in this guy here, for example, it doesn't have. It has a cloth simulation on it, but it doesn't have pressure enabled, and it doesn't have the pressure set to 5. The reason for that is, yes, we're copying the modifiers, but as you can see here, the modifier doesn't have settings in the modifier tab. The physics settings of the cloth simulation are actually somewhere else. So we're copying the cloth modifier with this node, but it doesn't have any settings. If we were, for example, let's take the icosphere and let's add a subdivision surface modifier on it so that it looks like this. And if I now execute the node tree, you can see the subdivision surface modifier is copied over, just like the cloth, and it's copied over with its settings. So if I select this and set it to 2 to make it look like this, execute the node tree. Now the copies also have these settings assigned to them. So the copy object modifier node takes the modifiers and the modifier settings, copies them, but the physics simulations, the cloth info, all the settings of the cloth sim, they're not part of the modifier, so they're not being copied. So how can we fix that? Well, first of all, I'm going to take this. Oh no, I'm going to take this off, execute again. So we look like this. Now, just like most of the time with animation nodes, as soon as you do anything in animation nodes, you have to like stick to animation nodes. You have to keep doing things in animation nodes. So we copied the modifier. Now let's also set the pressure and the pressure value of the cloth sim. How can we do that? Let's pick one of those. Let's look at the cloth sim here. Here we have a boolean, a checkbox for enable or disable pressure. And when we right click, we can go to copy data path, and then we can go to object set object attribute output. That's what it's called. In here we can assign to these 30 objects at the data path that we can paste in here, which is the use pressure. You can see here, use pressure. That's basically the checkbox, and we can set the checkbox to true. So let's do that. Here it says value has wrong type because we don't have a value yet. We need a boolean. We need to enable it, right? So now we're enabling cloth pressure. So we set the checkbox, but we don't have a value yet. Let's also set a value. So we need another object attribute output node for these objects. We don't want the pressure checkbox. We want actually this value here, which is again, right click and then copy data path, or you can do Shift Control C. But for the tutorials, I like to use whatever is shown on the screen. So here we have the uniform pressure force. That's the attribute that we're setting. We again don't have a value. What do we need? Well, we need a float. So we need a number float. Plug that in here. Set that to something 3. And now if we execute the node tree and we pick one of those particles, maybe let's take this donut. Look at this. It has pressure enabled and it has a pressure value of 3. This cube has pressure enabled and it has a value of 3. Awesome. So now we're actually instancing objects in animation nodes. They're all individual objects with their own individual pressure simulation or cloth simulation on it. And we're assigning the pressure checkbox set to true, and we're assigning a pressure value. Now, let's see if it actually works. How about we put how about we put a plane in here, scale it up, move it down, and enable collision on it. So we're expecting them to fall down and sort of bounce around because they're cloth simulations with pressure. So they should be colliding with the plane, not with each other. I'm not switching on collision on the 30 objects because then I think my recording will stutter. So let's hit play. This is already very slow. But you can see one thing. First of all, our original 3 objects here, they look correct. So they're doing something. They have pressure. They're falling down. But look at this cube. It doesn't look like this one. It doesn't look like it has the pressure really working for it. Oh, here I have a key not found error message. I think it's because the plane is now inside of the objects collection here, and the plane doesn't have, the plane has collision, it doesn't have, it's not part of the objects that we want to instance, right? So let's check this out, execute the node tree. Okay, so again, let's play with this. Let's hit play, let's see what happens. Now look at this. This original cube here behaves correctly. It has the pressure, stays like that until it hits the ground basically. But look at the other objects now. They go completely crazy. Why is that? The reason for that is this node tree here is being executed every time the frame changes. So for every step in our animation, we're executing this node tree. And we're assigning this Boolean value and the pressure value, and that sort of like completely throws off the cloth simulation. So what we have to do here is we can go back to our frame 1, switch off auto execution, and execute this node tree manually. This is basically our node tree for instancing, for setting up our scene that we want to animate. And all of this here, not this down here, this is for randomly distributing them, but all of this up here is basically just for instancing, assigning the cloth settings. So all of this is just for the instancing step that the particle system would do for us. Okay, but of course, like I said before, we still have the possibility to go in, change the objects inside of the collection, change settings, and it still works. We don't have to convert the particle system, and then we're stuck with that. So this is much more flexible, the animation nodes way. But now that I switched off auto execution, I can hit play and you can see now this looks correct. So we have 30 objects. Each one is its own physics simulation. That looks correct. They're all falling down, bouncing around. Again, they're not colliding with each other. I'm not going to switch on collision because that really slows things down. But of course, for the final render, you would probably want to do that. Okay, now before we continue, another thing that I want to show you here is now all of these objects have the pressure value of 3 because we're assigning 3 to the pressure force. What is it called? Uniform pressure force property or attribute, and we're assigning the value of 3. In our original objects, we had the cube and it had a pressure value of 3. The icosphere was 5. The torus is 2. So let's set the icosphere higher, maybe. No, or let's set it much lower so that it's really like cloth. What if we wanted to copy these settings over to our instances? Can we do that? Yes, of course we can. How can we do that? Well, first of all, we have to, here we're assigning an attribute value, but we can also read an attribute value. So let me get some space here. Oh, I need this for executing. So what do we need? Here we have our 3 original objects and we can go object, attribute, input. Okay, so we can get the object input, and you can see as soon as I plug this in, it says get list element because the get object attribute input only works on a single object. We can't plug a list of objects in here. So what do we need? We need a loop. Very, very easy, simple loop. Maybe create it up here. So shift a subprogram loop. What are we plugging in? We're plugging in a list of objects, which is a new object iterator to plug in here, and w invoke. So here we can plug in our 3 objects. Inside of the loop, we can now go plug this in here because it's a single object for each iteration. Which attribute do we need? Well, same thing as this one here. So we can just go in here, copy this data path over to here. So we have the uniform pressure force again, which gives us the value that we assigned in the cloth simulation in the original object. And what does this loop have to output? It should output a list of floats. So the loop here, new generate the output. Let's click here, create a float list and plug that in here, which converts our whatever value comes out of here into a float. That's fine. Awesome. So now here we have a float list and we can put this float list into this value. How can I do this so that it's clear what's happening? So we don't need this node anymore. We're now assigning the correct pressure value from our original objects in the collection. Let's see if it works. How can we see? The donuts should have a very low pressure value. So here it has a pressure value of 0.5, I said, or let's do 0.2, very low, but let's increase the cube to something very high, 10. Icosphere, and 3. Okay, so cube 10, icosphere 3, torus 0.2. Execute the node tree, and now let's check out this torus. It has a pressure of 0. Okay, so our node down here is not working. Oh, because we have to enable multiple values here, since we're now assigning a list and not a single value to this attribute anymore. Let's see, execute the node tree. How is this guy? 10. How's this torus? 0.2. This icosphere 3. It works. So now we're really copying the settings that we had in our original collection over to our objects, and I can hit the spacebar to play the animation, and you can see the torus objects here. They're very flimsy, floppy. The cubes, they have a lot of pressure in them, so they're hardly deforming. So this is working just fine. Cool. Now again, I want to come back to this issue here with switching off auto execution. Because now at the end of our huge node tree here, we have a list of objects. What if we wanted to change things over time or animate these objects after they've been pressurized and distributed and all of that? We can't do it anymore because this node tree now doesn't get executed throughout our animation. We only execute it when we hit the execute node tree button. There is also an easy solution for that, of course. So let me call this scene setup. So this node tree here is just for our scene setup. We go to frame 1, we hit execute node tree. If we wanted to change anything, we could go in and we could make 35 of those. Execute, and we have more. We can always come back to this node tree after we changed either the objects or maybe we added or removed something from the collection. We can come here and execute node tree with this button, which sets up our scene, our starting frame basically. That's why I call it scene setup. But we can create another animation nodes node tree. So we click here, we have a new node tree. And now let's say we want to play with the pressure value inside of this over time. Let's just do that. So we have a new node tree. This gets auto executed every time it changes, every time you change the node tree or the frame changes. So it's perfect for animation. And we can just take the object collection info of the animation nodes object container collection, which is this one here, where the other node tree puts all of the new objects, right? So we have 30 something objects in there now, and we can now use this node tree to do stuff with it. For example, how about we want to change the pressure value? So we want to object, again, attribute output. We want to set these objects. We want to change the pressure value, so this data path. Now you know what? We're gonna switch on and off pressure. Let's do that. Copy data path of the checkbox, paste that in here, use pressure, and then we can plug in a Boolean. And instead of just a Boolean checkbox, I'm gonna plug in a compare, and I'm gonna say if some value, what value, the animation node's time frame is greater than, I don't know, 50 frames, then it has pressure. No, let's say if it's less than 50. So if the frame here is less than 50, we have true, which switches on the pressure. And after 50, all of the objects shouldn't have any pressure anymore. So depending on their shape, you know, they will behave differently. Let's see if it works. Go back to frame 1, save the file, hit the spacebar, see what happens. So watch down here when we hit frame 50, what's gonna happen anytime now. 50, what's happening? Everything is collapsing because we switched off the pressure. Except for the original 3 objects that are still part of our simulation here, because they're, where are they? These 3 here. If you don't want to see those, you can always switch off the entire object collection here. And then we only get our particles. So again, hitting play, watching them all fall down. And here we are, frame 50. And everything is collapsing. No more pressure inside. Except for the icospheres. The round shapes are always different with the cloth simulation. They kind of keep their shape better. But they don't have any pressure enabled anymore. Here, checkbox is off now. And back here, checkbox is on. Okay, let me just switch back to my scene setup node here, full screen, so you know what's happening. So you can take a screenshot here. So this is basically our instancing, random position instancing, creating real objects that have modifiers assigned to them and that have the attributes of the cloth simulation set. Okay, now one last thing that you might be thinking while you're looking at all of this is, with the real particle system, you can distribute the particles inside of a volume of any mesh, not just a cube. This node down here, the random vector node, just gives us a random vectors with a certain length. So they're basically inside of a cube. Right, so go back to frame 1, execute node tree. So we get this. And how could we do this if we wanted to distribute our particles inside of something else? A very easy solution is to actually use a particle system. So I'm just gonna show you one last thing for this tutorial, because this is already crazy long. Let's say we have a monkey head. Scale it up, and we want to distribute all of our particles inside of this monkey head mesh. So why don't we just take a particle system, take 30 particles, emit them all on frame 1, and the source should be the volume random distribution inside of the volume. Okay, so now we have particles inside of Suzanne. And now we could go in here, and instead of using these random vectors, let's just use the particle system. Let me also switch Suzanne over to, where is it, wireframe. Oh, here we can see the particles, these little white dots. So instead of the random vectors here, we want to use the location of the particles. Of course, they should have, the particle system should have the same amount here. So what do we have? 35 random positions inside of Suzanne. Shift A, particle system, particles data, takes a particle system, so we have to take from object and take Suzanne, plug that in here, take the active particles, and here we have the locations. So instead of this random vector, we're gonna plug these random locations in here, then execute the node tree manually, and here we go. Now our 35 particles, which are not really particles but generated in animation nodes, are actually following the location of the particles of the real particle system inside of Suzanne. Alright, that's it for this tutorial. I hope you learned something new. I hope you enjoyed the video. If you did, please give it a thumbs up. Don't forget, you can subscribe for free right here on YouTube, and you can enable the notifications through that little bell icon so that you get a message when I make a new video. As always, the finished blend file of this tutorial can be downloaded over at my Patreon page for just $2 a month. And for just $5 a month, you also get all of my material packs for free, which you can also download individually from Blender Market. If you have any questions or suggestions, or if you just want to say hi, please drop me a note down below. You can also find me on Twitter and Instagram. Thank you for watching. Crispy out.